Welcome to myprojectbazaar.com. Project title: A location-wise predetermined deployment for optimizing lifetime in visual sensor networks. Let's say abstract. This project provides enhancement work of the paper. So, a wireless sensor network consists of spatially distributed autonomous sensors. Most of the network consists of static sensors which can be deployed in a wide environment for monitoring applications. While performing data transmission through multiple hops, it becomes less reliable. The sensor network broadcasts their status to the surroundings and receives status from other nodes to detect each other. Recently, actuator nodes perform diverse tasks have been introduced, and the sensors and the actuators can form a network which is called a wireless sensor actuator network. Also, visual sensor networks is a type of wireless sensor network in which it requires much more energy for sending and collecting data. In this, sensors collect a large amount of visual information which may be partially processed independently. It also provides some high-level services to the users so that the large amount of data can be distilled into information of interest using specific queries. In order to support the transmission of real-time data, different wireless modules that provide larger bandwidths can be considered. The amount of data collected from each visual sensors are transferred to the sink with large bandwidth and high energy. To increase the efficiency of the proposed system of our project, we enhance a distributed Gaussian-based algorithm that exploits iterative optimizations. This approach involves the local information between the neighbor nodes and select path by using the control packets. The simulation results show that the proposed approach with a new algorithm will increase the lifetime and achieve the reliable communication than the existing work. Now see the flow diagram. First, the network model is constructed. It includes the number of sensor nodes and the relay nodes in the transmission range. It has the energy and the channel which is assigned for each sensor and the relay nodes. Then the location of all nodes are gathered by the sink node. After that, a node deployment strategy is implemented, in which the relay nodes and the sensor nodes are placed in a specific location according to the sink location. Then the Gaussian routing is performed, which is the additional work of our project. It gathers the control packet's information and it establishes the path. If the path is established, then it transfers the data to the sink. Else, it again performs the routing process until a feasible path is established. Finally, the performance is analyzed for the proposed system with the existing system, that is, the proposed working paper. Now see the output demo. First, open the terminal window. Then go to the directory. Then run the code as ms space filename.tcl. Here 100 nodes are created and the positions of each and every nodes are updated for performing the routing procedures. These are the simulation time at microseconds. So at this level, the position of all nodes is updated here. The network admin window is opened now. To see the output, click on this window, and these are the number of nodes which are the sensors and the relays are placed here. This is the same node which are separated from the network transmission range. Now we are going to run the simulation. Here sync nodes are created and the sensors are deployed and the relay nodes are deployed. These are all performed by the node deployment strategies according to the sync location information. We can speed up the process. Now the routing packet is performed here. Here a sensor nodes which have the data for transmitted is forwarded to the relay node, and this relay node again forwards to the another relay node in the next layer of the network. Finally, the next layer relay node is transferred to the sink by finding the route. Path is established with the help of the control packets, which are represented as the route request and reply. So the information from the sensor node is finally transferred to the sink. To see the performance result, go to terminal window and type xgraph file name.txt to see the graph. This is the time delay graph for the data transmission from the sensor nodes to the sync node. To see the another graph, so this is the throughput graph that performed in the specific simulation time. So the times are mentioned here and the total number of packets, how much packets are delivered or represented here. So this is the performance level of the proposed system. Thank you for listening.